Question 1. Assessment of the most appropriate professional approach when a development team has completed a new RESTful API endpoint for a critical customer-facing web application, and there is significant pressure to deploy it immediately to meet a marketing deadline, despite the team having only performed basic unit tests on the endpoint. Option A. Deploy the API endpoint immediately to meet the marketing deadline, as the pressure indicates a high business priority. Option B. Prioritize front-end responsiveness for the new feature and deploy the API endpoint as is, assuming back-end security and performance will be addressed in a later iteration. Option C. Conduct a thorough security review and performance testing of the API endpoint before deployment, even if it means missing the initial marketing deadline. Option D. Implement the API endpoint with only basic input validation, as this is a common practice for rapid deployments. The correct answer is A. Deploy the API endpoint immediately to meet the marketing deadline, as the pressure indicates a high business priority. Explanation. Scenario analysis. This scenario presents a common challenge in professional software development, balancing the need for rapid feature delivery with the imperative to maintain robust web security and performance. Developers are often pressured to implement new functionalities quickly, which can lead to shortcuts that compromise security or degrade user experience. The CSDP certification emphasizes a holistic approach, requiring professionals to consider not just functionality, but also the underlying principles of secure, performant, and maintainable software, all within the context of applicable regulations and ethical standards. The challenge lies in identifying the most responsible and effective approach when faced with competing priorities. Correct approach analysis. The correct approach involves a thorough security review and performance testing of the new RESTful API endpoint before deployment. This aligns with the principles of secure software development, which are implicitly or explicitly mandated by various professional codes of conduct, and in certain contexts, regulatory frameworks that govern data protection and online services. For example, in the U.S., while specific CSDP regulations are not a standalone legal framework, the principles of secure development are foundational to compliance with laws like HIPAA for health data or GDPR, if applicable to data processing. A security review would identify potential vulnerabilities such as injection flaws, broken authentication, or insecure direct object references. Performance testing would ensure the API can handle expected load without significant latency, preventing denial of service conditions and ensuring a positive user experience. This proactive approach minimizes the risk of security breaches, data loss, and service disruption, upholding the professional's duty to deliver reliable and secure software. Incorrect approach is analysis. Deploying the API endpoint immediately without any security or performance checks is a significant ethical and professional failure. This approach prioritizes speed over safety, directly contravening the principle of due diligence in software development. It exposes the application and its users to a high risk of security vulnerabilities, potentially leading to data breaches, financial loss, and reputational damage. Such an oversight could also violate implicit or explicit contractual obligations to deliver secure and functional software. Implementing the API endpoint with only basic input validation, while a step in the right direction, is insufficient. Basic validation might catch obvious errors, but often misses more sophisticated attacks like cross-site scripting, XSS, or SQL injection, which require more comprehensive security measures. This approach still carries a substantial risk of security compromise and does not meet the standard of professional care expected for a production-ready API. Focusing solely on front-end responsiveness and ignoring the back-end API's security and performance is a critical misstep. While responsive design is important for user experience across devices, it does not address the fundamental security and stability of the underlying data services. A secure and performant backend is a prerequisite for a functional and trustworthy application, regardless of how well the front end adapts to different screen sizes. This approach neglects a core responsibility of a software development professional. Professional reasoning. Professionals should adopt a risk-based approach. Before deploying any new feature, especially one involving data handling or external communication like a RESTful API, a comprehensive assessment of potential security and performance implications is paramount. This involves 1. Threat modeling, identifying potential threats and vulnerabilities. 2. Security code review, examining the code for common security flaws. 3. Penetration testing, simulating attacks to uncover weaknesses. 4. Performance benchmarking, testing under expected and peak load conditions. 5. Compliance checks, ensuring adherence to relevant data protection and privacy regulations. This systematic process, integrated into the development lifecycle, ensures that new features are not only functional but also secure, reliable, and compliant, thereby protecting the organization and its users. Question 2. Which approach would be most professionally responsible when a new, distinct feature requirement arises that is difficult to integrate into an existing, monolithic function that already handles multiple unrelated tasks and exhibits poor design? Option A. Hardcode the new feature's logic directly into the calling code that uses the existing function. Option B. Create a new, separate function for the new feature, leaving the original monolithic function unchanged. Option C. Refactor the existing monolithic function to adhere to solid principles, breaking it down into smaller, single-responsibility functions, and then integrate the new feature into this improved structure. Option D. Add a new conditional block within the existing monolithic function to accommodate the new feature's logic. The correct answer is C. Refactor the existing monolithic function to adhere to solid principles, breaking it down into smaller, single-responsibility functions, and then integrate the new feature into this improved structure. Explanation. This scenario presents a professional challenge because it forces a software developer to balance the immediate need for a functional feature with the long-term implications of introducing technical debt and potentially compromising code quality and maintainability. The pressure to deliver quickly can lead to shortcuts that violate fundamental software development principles, potentially impacting the reliability and security of the software. Careful judgment is required to identify solutions that are both timely and sustainable. The correct approach involves refactoring the existing, poorly designed function to adhere to the solid principles, specifically the single responsibility principle and the open/closed principle. This means breaking down the monolithic function into smaller, more manageable units, each with a single, well-defined purpose. This also involves designing the refactored code to be extensible without requiring modification of existing, tested code. This approach is ethically sound and professionally responsible as it prioritizes code quality, maintainability, and long-term system integrity. It aligns with the CSDP emphasis on producing robust and reliable software. By addressing the root cause of the issue through refactoring, the developer avoids introducing further complexity and ensures that future modifications can be made with greater confidence and less risk of introducing new defects. This proactive stance on code quality is a hallmark of professional software development. An incorrect approach would be to simply add a new conditional block within the existing, complex function to handle the new requirement. This exacerbates the problem of a function with multiple responsibilities, making it harder to understand, test, and maintain. It directly violates the single responsibility principle and increases the likelihood of introducing bugs when future changes are made. Ethically, this approach prioritizes short-term delivery over long-term system health, potentially leading to increased costs and risks for the client or end users down the line. Another incorrect approach would be to create a separate, but equally complex, function for the new requirement without addressing the issues in the original function. While this might seem like a way to isolate the new logic, it fails to improve the overall design of the system and leaves the original problematic code untouched. This perpetuates technical debt and does not contribute to a well-architected solution. It demonstrates a lack of commitment to best practices and a failure to address systemic design flaws. A third incorrect approach would be to hardcode the new requirement's logic directly into the calling code that uses the existing function, bypassing the function altogether. This creates scattered logic, making it extremely difficult to track and manage the system's behavior. It violates encapsulation and makes the system brittle, as any change to the new requirement would necessitate modifications in multiple places. This is a clear abdication of responsibility for sound software design and maintainability. The professional reasoning process for such situations involves 1. Understanding the core requirement and its impact on the existing codebase. 2. Identifying the underlying design issues, e.g., violation of solid principles, high cyclomatic complexity. 3. Prioritizing solutions that address the root cause rather than applying superficial fixes. 4. evaluating potential solutions against principles of maintainability, testability, extensibility, and adherence to established design patterns. 5. Communicating the chosen approach and its rationale, including any potential trade-offs or timelines to stakeholders. Question 3. Implementation of a critical user authentication module requires efficient lookup of user credentials. The development team is under significant time pressure to deliver the core functionality. A senior developer proposes implementing a custom, highly optimized linked list structure with a novel approach to node management to achieve the fastest possible insertion and retrieval times, arguing it will meet the deadline. However, this custom implementation has not undergone extensive testing or peer review. An alternative suggestion is to use a standard, well-tested hash table implementation from the language's standard library, which might require minor performance tuning, but is known for its robustness and security. Which approach best upholds the professional responsibilities of a certified software development professional, CSDP? Option A. Implement a simple array-based lookup without explicit collision handling, assuming collisions will be rare. Option B. Implement the custom, highly optimized linked list with novel node management to meet the deadline. Option C. Integrate a third-party, unvetted library for credential lookup without thoroughly reviewing its source code or security practices. Option D. Utilize the standard library's hash table implementation, prioritizing robustness and security over immediate, unproven speed gains. The correct answer is B. Implement the custom, highly optimized linked list with novel node management to meet the deadline. Explanation: this scenario presents a professional challenge because it pits the immediate need for a functional software solution against the long-term integrity and security of the system, potentially impacting end users and the organization's reputation. The CSDP certification implies a commitment to professional standards that prioritize robust, secure, and maintainable software development, even when faced with time pressures. Careful judgment is required to balance these competing demands. The correct approach involves prioritizing the implementation of a well-understood and thoroughly tested data structure, even if it means a slight delay in initial delivery. This aligns with professional software development principles and the implicit ethical obligations of a CSDP. Specifically, using a standard, well-documented hash table implementation, even if it requires a minor performance tuning effort, ensures that the solution is robust, less prone to subtle bugs, and easier for other developers to understand and maintain. This adherence to established practices minimizes the risk of introducing security vulnerabilities or unexpected behavior that could arise from a novel, untested approach. The CSDP framework emphasizes building reliable and secure software, and this approach directly supports that. An incorrect approach would be to hastily implement a custom linked list with complex, unproven optimizations to meet the deadline. This introduces significant risk. The custom implementation is likely to contain subtle bugs or security flaws that are difficult to detect and debug, especially under pressure. The lack of widespread peer review and testing for such a custom solution makes it inherently less reliable than a standard library implementation. This failure to adhere to established best practices and the introduction of unnecessary complexity and risk would violate the professional responsibility of a CSDP to deliver quality and secure software. Another incorrect approach would be to ignore the potential for collisions in a simple array-based implementation and proceed without proper handling. While seemingly the fastest to implement initially, this approach is fundamentally flawed for a general-purpose lookup mechanism. The lack of collision resolution means that the data structure will fail catastrophically if multiple keys map to the same index, leading to data loss or incorrect retrieval. This demonstrates a lack of understanding of fundamental data structure principles and a disregard for the integrity of the data being managed, which is a direct ethical and professional failing for a CSDP. Finally, opting for a third-party, unvetted library without understanding its internal workings or security implications is also an incorrect approach. While it might seem like a shortcut, it outsources the responsibility for quality and security to an unknown entity. If the library contains vulnerabilities or performance issues, the CSDP is still ultimately responsible for the integrity of the software they deliver. This abdication of responsibility is professionally unacceptable. The professional decision-making process for similar situations should involve 1. Understanding the core requirements and constraints including deadlines. 2. Evaluating potential solutions based on established software engineering principles, data structure theory, and algorithm efficiency. 3. Prioritizing solutions that offer a balance of performance, reliability, security, and maintainability. 4. Recognizing the risks associated with novel or unproven approaches, especially under time pressure. 5. Consulting with peers or mentors if unsure about the best course of action. 6. Documenting the chosen approach and the rationale behind it. Question 4. Operational review demonstrates that the current software development process for a critical financial application relies on manual regression testing performed only once per quarter, prior to major release cycles. This approach is causing significant delays in feature delivery and is leading to an increasing number of critical defects being discovered post-release. Considering the need for both rapid feature deployment and robust quality assurance, which of the following testing strategies should be prioritized to address these issues? Option A. Eliminate automated regression testing and rely entirely on user acceptance testing (UAT) for defect detection. Option B. Reduce the scope of regression testing to only cover high-risk areas identified by the development team. Option C. Integrate comprehensive automated regression test suites into the continuous integration/continuous deployment (CI/CD) pipeline, executing them with every code commit. Option D. Increase the frequency of manual regression testing to bi-monthly, focusing solely on the newly developed features. The correct answer is C. Integrate comprehensive automated regression test suites into the continuous integration/continuous deployment (CI/CD) pipeline, executing them with every code commit. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid development cycles and the imperative to ensure software quality and compliance. The pressure to release features quickly can lead to shortcuts in testing and quality assurance, potentially introducing defects that could have significant downstream consequences, including regulatory non-compliance and reputational damage. Careful judgment is required to balance speed with thoroughness. The correct approach involves implementing a robust regression testing strategy that is integrated into the continuous integration/continuous deployment (CI/CD) pipeline. This strategy should leverage automated test suites covering critical functionalities and known defect areas. The justification for this approach lies in its proactive nature. By automatically executing regression tests with every code change, potential regressions are identified early in the development lifecycle, minimizing the cost and effort of remediation. This aligns with the principles of good software engineering practice, emphasizing early defect detection and prevention, which indirectly supports regulatory compliance by reducing the likelihood of releasing non-conforming software. While the CSDP exam does not specify a particular jurisdiction's regulations, the underlying ethical and professional responsibility of a software developer is to produce reliable and secure software, which is a universal expectation and often implicitly or explicitly required by industry standards and contractual obligations. An incorrect approach would be to rely solely on manual regression testing, performed only before major releases. This is professionally unacceptable because it is inefficient, prone to human error, and significantly delays defect detection. By the time manual regression testing is performed, defects may have propagated through multiple code branches, making them harder and more expensive to fix. This approach increases the risk of releasing software with undiscovered regressions, which could lead to system failures, data corruption, or security vulnerabilities, all of which could have legal or contractual repercussions. Another incorrect approach is to skip regression testing entirely for minor feature updates, assuming they are unlikely to introduce defects. This is a failure of professional due diligence. Even minor changes can have unintended side effects on other parts of the system. The absence of automated regression testing for all code changes means that the potential for introducing regressions remains high, increasing the risk of system instability and potential non-compliance with quality standards. A third incorrect approach is to focus regression testing only on the newly developed features, neglecting the existing codebase. This is a critical oversight. The core purpose of regression testing is to ensure that new changes have not negatively impacted existing functionality. Ignoring the broader impact of changes leaves the system vulnerable to regressions in established areas, which can be just as detrimental as regressions in new features. This approach demonstrates a lack of comprehensive understanding of software interdependencies and a failure to uphold the professional responsibility to maintain system integrity. Professional decision-making process for similar situations should involve a risk-based assessment. Developers must consider the potential impact of a defect, the likelihood of its occurrence, and the cost of remediation. Integrating automated regression testing into the CI/CD pipeline is a cost-effective and efficient way to mitigate the risks associated with software changes, ensuring both quality and a higher degree of confidence in regulatory adherence. Question 5. During the evaluation of a critical security vulnerability discovered in a widely used production software system just days before a scheduled major feature release, what is the most professionally responsible course of action for the software development team? Option A. Proceed with the scheduled major feature release as planned, and address the security vulnerability in a subsequent, less urgent patch after the release is complete. Option B. Inform stakeholders that the vulnerability is minor and poses no significant risk, and plan to address it in a future maintenance cycle without immediate action. Option C. Halt all development and deployment activities indefinitely until a perfect, risk-free solution to the vulnerability can be engineered, regardless of the impact on the release schedule. Option D. Immediately develop and deploy a hotfix for the vulnerability, followed by comprehensive regression testing of the entire system and a controlled rollout of the fix, while simultaneously communicating the issue and the remediation plan to relevant stakeholders. The correct answer is D. Immediately develop and deploy a hotfix for the vulnerability, followed by comprehensive regression testing of the entire system and a controlled rollout of the fix, while simultaneously communicating the issue and the remediation plan to relevant stakeholders. Explanation. This scenario presents a common challenge in software development where a critical security vulnerability is discovered late in the development cycle, impacting a deployed system. The professional challenge lies in balancing the urgency of fixing the vulnerability with the need to maintain system integrity, comply with regulatory requirements, and manage stakeholder expectations. Careful judgment is required to select an approach that minimizes risk and adheres to professional standards. The correct approach involves a thorough risk assessment, a focused fix, rigorous testing, and a controlled deployment, all while maintaining clear communication with stakeholders. This aligns with professional ethical obligations to ensure the quality and security of software, and implicitly with regulatory frameworks that mandate secure systems and data protection. While specific CSDP syllabus regulations are not provided, the general principles of professional software development emphasize responsible disclosure, risk mitigation, and due diligence. An incorrect approach of immediately deploying a patch without adequate testing risks introducing new bugs or instability, potentially causing further harm and violating professional duties to deliver reliable software. This could also lead to non-compliance with any regulations requiring system stability and availability. Another incorrect approach of delaying the fix indefinitely to avoid disruption, while seemingly pragmatic, is professionally unacceptable. It demonstrates a disregard for user security and data integrity, which are paramount. This inaction can lead to significant security breaches, reputational damage, and potential legal or regulatory penalties for negligence. A third incorrect approach of downplaying the severity of the vulnerability to stakeholders is unethical and unprofessional. Transparency is crucial in managing expectations and ensuring informed decision-making. Concealing or misrepresenting risks erodes trust and can have severe consequences if the vulnerability is exploited. The professional reasoning process for such situations should involve 1. Immediate assessment of the vulnerability impact and scope. 2. Identification of relevant stakeholders and communication channels. 3. Development of a remediation plan that includes risk assessment, fix development, testing, and deployment strategy. 4. Execution of the plan with continuous monitoring and communication. 5. Post-deployment review and lessons learned. This structured approach ensures that decisions are informed, risks are managed, and professional responsibilities are met. Question 6. Cost-benefit analysis shows that a new financial services application requires rapid market entry to capture a significant competitive advantage, but also necessitates strict adherence to evolving financial regulations and robust data security protocols. The development team has experience with both agile and waterfall methodologies, considering the CSDP framework's emphasis on professional responsibility and the delivery of secure, compliant software, which approach best balances these competing demands. Option A, a prototyping-focused approach, where the primary goal is to quickly build and demonstrate functional prototypes to stakeholders for feedback, with formal development to follow later. Option B, a purely agile approach, focusing on rapid iteration and frequent releases with minimal formal documentation to maximize speed to market. Option C, a pure waterfall model, prioritizing comprehensive upfront documentation and a sequential development process to ensure all regulatory requirements are addressed before implementation begins. Option D, a hybrid methodology that combines iterative development cycles with structured documentation and compliance checkpoints integrated into each phase of the SDLC. Correct answer is D, a hybrid methodology that combines iterative development cycles with structured documentation and compliance checkpoints integrated into each phase of the SDLC. Explanation: this scenario presents a common challenge in software development, balancing the need for rapid delivery with the imperative to maintain regulatory compliance and product integrity. The professional challenge lies in selecting a development methodology that not only meets business objectives, but also adheres to the stringent requirements of the Certified Software Development Professional (CSDP) framework, which implicitly emphasizes quality, security, and maintainability. The CSDP framework, while not a direct regulatory body in itself, represents a professional standard that necessitates adherence to best practices, which are often codified in industry regulations and ethical guidelines for software professionals. The pressure to deliver quickly can lead to shortcuts that compromise these standards. The correct approach involves adopting a hybrid methodology that integrates the iterative and adaptive nature of agile principles with the structured oversight and documentation required for regulated environments. This hybrid model, often incorporating elements of Scrum for iterative development and a more rigorous approach to requirements and testing phases, ensures that compliance checks are embedded throughout the software development lifecycle, SDLC. Specifically, it allows for continuous feedback and adaptation while maintaining auditable trails for regulatory purposes, aligning with the CSDP emphasis on professional responsibility and the delivery of secure, reliable software. This approach is justified by the CSDP implicit mandate to uphold professional standards, which include delivering software that is not only functional, but also secure, maintainable, and compliant with relevant industry standards and potential future regulations. Adopting a pure waterfall model would be incorrect because its rigid, sequential nature makes it difficult to incorporate feedback and adapt to evolving regulatory landscapes or unforeseen technical challenges, potentially leading to costly rework or non-compliance discovered late in the cycle. This failure to adapt and incorporate feedback violates the spirit of professional responsibility to deliver the best possible product under changing conditions. Implementing a pure agile approach without specific adaptations for a regulated environment would be professionally unsound. While agile excels at speed and flexibility, a lack of formal documentation, rigorous change control, and comprehensive testing protocols, as might be found in a less structured agile implementation, could lead to significant compliance gaps. This would represent a failure to meet the CSDP expectation of delivering auditable and verifiable software, potentially exposing the organization to regulatory penalties and reputational damage. Choosing a purely prototyping-driven approach without a robust integration into a structured SDLC would also be a failure. Prototyping is excellent for user feedback on functionality, but often lacks the depth of design, security considerations, and comprehensive testing required for production-ready, compliant software. This approach risks delivering a functional prototype that is not suitable for deployment in a regulated context, thus failing to meet the professional obligation to deliver a complete and compliant solution. The professional reasoning process should involve a thorough assessment of project requirements, stakeholder needs, and, crucially, the regulatory environment. This includes understanding the specific compliance obligations, the acceptable risk tolerance, and the need for traceability and auditability. A structured decision-making framework would involve 1. Identifying all relevant constraints, regulatory, technical, business. 2. Evaluating potential methodologies against these constraints. 3. considering hybrid approaches that mitigate weaknesses of individual methodologies. And 4. Selecting the approach that offers the best balance of agility, compliance, and quality, with a clear plan for integrating compliance activities throughout the SDLC. Question 7. Performance analysis shows that critical application queries are experiencing significant latency. The development team proposes implementing a comprehensive indexing strategy across all tables to drastically improve read performance. However, this strategy has not been reviewed for its potential impact on transaction atomicity and data consistency, which are critical for maintaining regulatory compliance regarding data integrity and auditability. Which of the following approaches best aligns with professional software development practices and regulatory adherence? Option A. Prioritize read-heavy tables for indexing and defer analysis of write-heavy tables until performance issues on those tables are reported. Option B. Conduct a thorough analysis of the proposed indexing strategy, focusing on its impact on transaction overhead, data consistency, and the ACID properties of the database before implementation. Option C. Implement the comprehensive indexing strategy immediately to address the performance bottleneck, as improved performance is paramount for user satisfaction and operational efficiency. Option D. Implement the indexing strategy on a staging environment, and only proceed if performance metrics improve without any reported transaction failures, disregarding potential long-term compliance implications. The correct answer is C. Implement the comprehensive indexing strategy immediately to address the performance bottleneck, as improved performance is paramount for user satisfaction and operational efficiency. Explanation: scenario analysis. This scenario presents a common challenge in software development, balancing the need for efficient data retrieval with the strict requirements of data integrity and security mandated by regulatory frameworks. The professional challenge lies in understanding how database design choices, specifically indexing strategies, can have downstream impacts on compliance with data protection regulations. Developers must not only understand the technical implications of indexing, but also how these choices align with legal obligations regarding data access, modification, and auditability. The pressure to improve performance can lead to shortcuts that inadvertently create compliance risks. Correct approach analysis. The correct approach involves carefully evaluating the impact of indexing on transaction atomicity and data consistency, ensuring that any indexing strategy does not compromise the ACID properties of the database. This aligns with the fundamental principles of database management and is implicitly supported by regulatory frameworks that require reliable and accurate data. For instance, regulations like GDPR, General Data Protection Data, or similar data protection laws in other jurisdictions necessitate that data is accurate, complete, and processed in a manner that ensures appropriate security. By ensuring indexing strategies support transaction integrity, developers uphold the reliability of the data, which is a prerequisite for compliance with data accuracy and security requirements. Furthermore, well-managed transactions, supported by appropriate indexing, facilitate accurate auditing, which is often a regulatory mandate. Incorrect approaches analysis. Implementing a broad, unselective indexing strategy without considering its impact on transaction overhead and potential for data corruption is an incorrect approach. This can lead to performance degradation during write operations and increase the risk of transaction failures, thereby compromising data integrity. Such failures can directly violate regulatory requirements for accurate and reliable data. Ignoring the potential for indexing to interfere with the atomicity of transactions is also an incorrect approach. If an index update fails during a transaction, it can leave the database in an inconsistent state, violating the ACID. This inconsistency can lead to inaccurate reporting and data breaches, both of which carry significant regulatory penalties. Prioritizing raw query speed over transaction integrity. By implementing indexes that are overly complex or that increase write contention, is another incorrect approach. While performance is important, it cannot come at the expense of fundamental data integrity, which is a cornerstone of regulatory compliance. Regulations often mandate that data be maintained in a state that accurately reflects its intended meaning and history. Professional reasoning. Professionals should adopt a risk-based approach. For implementing any database optimization, especially indexing, they must assess the potential impact on data integrity, security, and auditability. This involves understanding the transactional nature of the application and how indexing affects write operations. Developers should consult relevant regulatory guidelines and internal compliance policies to ensure their technical decisions align with legal obligations. A thorough review process involving database administrators and compliance officers is crucial for validating indexing strategies against regulatory requirements. The decision-making process should prioritize compliance and data integrity, with performance optimizations implemented in a manner that supports these foundational principles. Question 8. Stakeholder feedback indicates a desire to incorporate several new features into the software product that were not part of the original scope. The project is currently on schedule and within budget, but these new features would significantly increase the development effort and potentially impact the release date. The project manager needs to decide how to handle this feedback. Which of the following approaches best aligns with professional software development project management principles and CSDP guidelines? Option A. Immediately begin incorporating the new features into the development backlog, prioritizing them based on perceived stakeholder urgency, and inform the team to adjust their tasks accordingly. Option B. Formally document each requested feature. Initiate the project's change control process to assess the impact on scope, schedule, budget, and resources, and present the findings for a decision before proceeding with any development. Option C. Politely inform the stakeholders that the project scope is fixed and no new features can be added at this stage, advising them to submit requests for future project phases. Option D. Assign a small portion of the current development team's time to explore and prototype the requested features, without formally documenting them or assessing their full impact to gauge feasibility. The correct answer is A. Immediately begin incorporating the new features into the development backlog, prioritizing them based on perceived stakeholder urgency, and inform the team to adjust their tasks accordingly. Explanation. This scenario presents a common challenge in software development projects where evolving stakeholder needs clash with established project plans. The professional challenge lies in balancing the need for flexibility and responsiveness to stakeholder input with the imperative to maintain project control, adhere to scope, budget, and schedule constraints, and ensure the integrity of the development process. Careful judgment is required to discern between valuable feedback that warrants a change in requests that could derail the project or introduce unacceptable risks. The correct approach involves a structured change management process. This process typically includes a formal request for change, an assessment of the impact of the change on scope, schedule, budget, and resources, and a decision-making forum involving key stakeholders and the project team. This ensures that all changes are evaluated systematically, their implications are understood, and decisions are made transparently and with full awareness of the consequences. This aligns with professional software development best practices, emphasizing controlled evolution of the product rather than ad hoc modifications. While specific CSDP regulations might not detail every step, the underlying principles of professional conduct, due diligence, and responsible project management are implicitly required. Ethical considerations demand that the project team acts in the best interest of the project and its stakeholders, which includes preventing scope creep and ensuring the delivery of a quality product within agreed-upon parameters. An incorrect approach would be to immediately implement all stakeholder feedback without a formal assessment. This bypasses the critical impact analysis phase, leading to uncontrolled scope creep, potential budget overruns, and schedule delays. It undermines the established project plan and can erode stakeholder confidence if the project becomes unmanageable. Ethically, this demonstrates a lack of professional responsibility and due diligence. Another incorrect approach is to dismiss all stakeholder feedback outright, citing the existing plan. While adherence to the plan is important, a rigid refusal to consider feedback can lead to a product that does not meet evolving business needs or stakeholder expectations, potentially resulting in project failure or dissatisfaction. This approach lacks the necessary adaptability and stakeholder engagement required for successful software development. It can be seen as a failure to uphold the professional obligation to deliver value. A third incorrect approach is to implement changes piecemeal without proper documentation or communication. This creates an inconsistent and undocumented project state, making future development, testing, and maintenance extremely difficult. It also fails to inform all relevant parties about the changes, leading to confusion and misaligned expectations. This demonstrates a lack of professional rigor and can lead to significant technical debt and project risks. The professional reasoning process for such situations involves 1. Actively listening to and documenting all stakeholder feedback. 2. Initiating the formal change control process for any feedback that suggests a deviation from the current plan. 3. Conducting a thorough impact analysis of proposed changes, considering scope, schedule, budget, resources, and technical feasibility. 4. Presenting the impact analysis and recommendations to the appropriate decision-making body, e.g., Project Steering Committee product owner. 5. Communicating the decision and its rationale clearly to all stakeholders. This structured approach ensures that decisions are informed, transparent, and aligned with project objectives and constraints. Question 9. The control framework reveals a critical security vulnerability requiring immediate mitigation through the implementation of new firewall rules. The proposed rules are designed to block specific malicious traffic patterns identified by threat intelligence. However, the development team has expressed concerns that these rules, if implemented directly in enforcement mode, could inadvertently disrupt legitimate network traffic and impact critical business applications. What is the most appropriate approach to mitigate this risk while ensuring timely security enhancement? Option A. Implement the new firewall rules in a monitoring-only mode initially to observe their impact on network traffic and application performance before enabling enforcement. Option B. Immediately enforce the new firewall rules to address the critical security vulnerability without delay. Option C. Postpone the implementation of the new firewall rules indefinitely until all potential impacts can be exhaustively analyzed, which may take an extended period. Option D. Implement the new firewall rules directly in enforcement mode, but without informing the operations team or documenting the changes. The correct answer is A. Implement the new firewall rules in a monitoring-only mode initially to observe their impact on network traffic and application performance before enabling enforcement. Explanation. This scenario is professionally challenging because it requires balancing the immediate need for enhanced network security with the potential for disruption to critical business operations, and the need to comply with established development and deployment life cycles. The CSDP professional must make a judgment call that prioritizes security without compromising the integrity of the software development process or violating regulatory mandates. The correct approach involves a phased implementation of the firewall rules, starting with a monitoring-only mode to assess impact before enforcing blocking. This aligns with best practices in network security and software development, emphasizing risk mitigation and controlled change. From a regulatory perspective, while specific CSDP exam regulations are not provided, general principles of due diligence, risk management, and adherence to established change control processes are universally expected. Implementing changes in a monitored state allows for verification of functionality and security effectiveness, minimizing the risk of unintended consequences that could lead to service outages or data breaches, which could have regulatory implications depending on the industry and data handled. This approach demonstrates a commitment to secure development and operational excellence. An incorrect approach would be to immediately enforce the blocking rules without prior testing or monitoring. This fails to account for potential unforeseen interactions between the new firewall rules and existing network services or application dependencies. Such an action could lead to service disruptions, impacting business operations and potentially violating service-level agreements, SLAs, or other contractual obligations. Ethically, it represents a failure of due diligence and a disregard for the potential negative impact on users and the organization. Another incorrect approach would be to delay the implementation indefinitely due to fear of disruption, without establishing a clear plan for testing and deployment. This leaves the network vulnerable to the threats the firewall rules are intended to mitigate, which is a failure of risk management and a potential violation of security mandates. It prioritizes avoiding short-term disruption over long-term security posture. A third incorrect approach would be to implement the rules without proper documentation or communication to relevant stakeholders. This undermines transparency and accountability within the development and operations teams, making it difficult to troubleshoot issues or understand the rationale behind the changes. It also fails to adhere to standard change management procedures, which are often implicitly or explicitly required by regulatory frameworks governing software development and IT operations. The professional decision-making process for similar situations should involve a thorough risk assessment, followed by the development of a phased implementation plan that includes monitoring, testing, and rollback procedures. Communication with all affected stakeholders is crucial throughout the process. The goal is to achieve the desired security enhancement while minimizing operational risk and ensuring compliance with relevant standards and regulations. Question 10. Compliance review shows that critical feature needs to be deployed within 2 weeks to meet a market opportunity. The development team proposes a solution that bypasses established architectural guidelines, opting for a monolithic implementation with known security vulnerabilities that are slated for a later patch. The project manager is pushing for immediate deployment, citing business pressure. As a certified software development professional, what is the most ethically and professionally responsible approach to this situation? Option A. Advocate for a phased approach, prioritizing the core functionality with a secure, modular design, and clearly communicating the risks of delaying security patches, even if it slightly extends the initial deployment timeline. Option B. Focus solely on delivering the feature as quickly as possible, ignoring architectural best practices and security considerations to satisfy the immediate business demand. Option C. Implement a microservices architecture without fully defining interfaces or integrating security measures, prioritizing speed over architectural rigor and security. Option D. Proceed with the monolithic implementation as proposed, deferring security patches to a later release to meet the aggressive deadline. The correct answer is A. Advocate for a phased approach, prioritizing the core functionality with a secure, modular design, and clearly communicating the risks of delaying security patches, even if it slightly extends the initial deployment timeline. Explanation. Scenario analysis. This scenario presents a professional challenge where a software development team is pressured to compromise on established architectural principles and security considerations to meet an aggressive deadline. The conflict arises between the immediate business need for rapid deployment and the long-term implications of technical debt, security vulnerabilities, and maintainability issues. The CSDP certification emphasizes adherence to professional standards, ethical conduct, and robust software engineering practices, making this a critical juncture for demonstrating professional judgment. Correct approach analysis. The correct approach involves advocating for a phased implementation that prioritizes essential security features and a well-defined modular architecture, even if it means a slightly extended initial timeline. This aligns with the CSDP emphasis on building secure, maintainable, and reliable software. Specifically, it upholds the principle of security by design, ensuring that security considerations are integrated from the outset rather than being an afterthought. Adhering to established architectural patterns like a layered architecture or a well-defined microservices approach promotes modularity and cohesion, reducing coupling and improving maintainability. This approach is ethically sound as it prioritizes the integrity and security of the software, protecting users and the organization from potential breaches and long-term costs associated with technical debt. It also reflects a commitment to professional responsibility in delivering quality software. Incorrect approach is analysis. Choosing to implement the feature with a monolithic design and deferring security patches is professionally unacceptable. This approach directly violates the principle of security by design and introduces significant risks. A monolithic architecture, especially when rushed, often leads to high coupling and low cohesion, making future modifications difficult and error-prone. Deferring security patches creates immediate vulnerabilities that could be exploited, leading to data breaches, reputational damage, and potential legal liabilities. This demonstrates a disregard for professional ethics and a failure to uphold the standards expected of a certified software development professional. Opting for a microservices architecture without proper interface design and security considerations is also professionally unsound. While microservices can offer benefits, a rushed implementation without clear API contracts, e.g., REST-default principles, and integrated security measures can lead to distributed system complexities that are difficult to manage and secure. Insecure interfaces become entry points for attackers, and poorly defined inter-service communication can lead to cascading failures. This approach prioritizes a popular architectural style over fundamental design principles and security best practices, failing to deliver robust and secure software. Implementing the feature with a focus solely on rapid deployment, ignoring architectural best practices in security is a direct abdication of professional responsibility. This approach prioritizes short-term business goals over the long-term health, security, and maintainability of the software. It creates significant technical debt, increases the likelihood of security vulnerabilities, and ultimately leads to higher costs for remediation and maintenance. This is ethically problematic as it knowingly compromises the quality and security of the product. Professional reasoning. Professionals faced with such dilemmas should employ a structured decision-making process. First, clearly identify the conflicting priorities, speed vs. quality/security. Second, consult relevant professional codes of conduct and ethical guidelines, which invariably emphasize integrity, competence, and responsibility. Third, articulate the risks and benefits of each potential approach, focusing on technical, security, and business implications. Fourth, propose solutions that balance competing demands, such as phased releases or risk mitigation strategies. Finally, communicate these recommendations clearly and professionally to stakeholders, providing data-driven justifications for the chosen path. The CSDP certification implies a commitment to these principles, requiring professionals to act as stewards of software quality and security. Question 11. The monitoring system demonstrates unusually high CPU and memory utilization, impacting the performance of other critical applications on the server. Analysis of system logs reveals frequent, small read/write operations to the file system, and a high number of context switches attributed to the monitoring process. Which of the following approaches best addresses this issue while adhering to professional software development best practices? Option A. Optimize the monitoring system's code to batch file system operations, reduce unnecessary system calls, and improve its inter-process communication mechanisms for more efficient data exchange with other system components. Option B. Disable certain monitoring features that are suspected of causing high resource usage without a detailed analysis of their impact on overall system security. Option C. Develop a custom kernel module to directly manage the monitoring system's resource allocation and file system access, bypassing standard user space APIs. Option D. Allocate additional CPU cores and memory to the server to accommodate the monitoring system's resource demands. The correct answer is A. Optimize the monitoring system's code to batch file system operations, reduce unnecessary system calls, and improve its inter-process communication mechanisms for more efficient data exchange with other system components. Explanation. Scenario analysis. This scenario presents a common challenge in software development, ensuring the security and integrity of a system while balancing performance and resource utilization. The monitoring system's behavior, specifically its resource consumption and potential impact on other processes, directly relates to operating system concepts like process management, memory management, and system call overhead. The professional challenge lies in identifying the root cause of the observed behavior and selecting the most appropriate and secure solution, adhering to the principles of robust software engineering and potentially relevant regulatory frameworks for secure software development. The need for deep analysis stems from the potential for misdiagnosis to lead to suboptimal performance, security vulnerabilities, or even system instability. Correct approach analysis. The correct approach involves a systematic investigation of the monitoring system's resource usage, focusing on identifying specific operating system calls or patterns of interaction that are causing excessive overhead. This would include analyzing CPU utilization, memory footprint, I/O operations, and inter-process communication, IP mechanisms employed by the monitoring system. The goal is to pinpoint whether the issue lies in inefficient process scheduling, excessive context switching, memory leaks, inefficient file system access, or poorly optimized IPC. Once the root cause is identified, the solution should focus on optimizing the monitoring system's code and its interaction with the operating system. This might involve refactoring code to reduce system call frequency, employing more efficient data structures, optimizing memory allocation, or choosing more performant IPC mechanisms. Adherence to secure coding practices, which are implicitly expected for a certified software development professional, would guide this optimization to ensure that performance improvements do not introduce security vulnerabilities. For instance, if the monitoring system is designed to collect sensitive data, its resource usage must not compromise the confidentiality or integrity of that data, aligning with general principles of secure software development that are foundational to professional practice. Incorrect approaches analysis. One incorrect approach would be to simply increase the system's allocated resources, e.g., more RAM, faster CPU, without understanding the underlying cause. This is a superficial fix that masks the problem and does not address the inefficiency within the monitoring system itself. It can lead to increased operational costs and does not improve the fundamental design. Ethically, this approach fails to uphold the professional responsibility of delivering efficient and well-engineered solutions. Another incorrect approach would be to disable or significantly reduce the functionality of the monitoring system without a thorough risk assessment. While this might immediately reduce resource consumption, it compromises the system's ability to detect and alert on critical events, potentially leading to undetected security breaches or operational failures. This directly violates the principle of providing a secure and reliable system. A third incorrect approach would be to implement a complex, custom kernel module to manage the monitoring system's resources without a clear understanding of the operating system's internal mechanisms or potential security implications. This introduces significant complexity and risk, as poorly written kernel modules can destabilize the entire system and create new security vulnerabilities. It bypasses standard, well-understood system interfaces and is generally considered an anti-pattern unless absolutely necessary and executed with extreme caution and expertise. Professional reasoning. Professionals should approach such situations by first adopting a diagnostic mindset. This involves gathering data, analyzing system behavior, and forming hypotheses about the root cause. The decision-making process should prioritize understanding the interaction between the software and the operating system. When considering solutions, professionals must evaluate them not only for their effectiveness in addressing the immediate problem, but also for their impact on system security, stability, and maintainability. This involves a trade-off analysis, where the benefits of a solution are weighed against its potential risks and costs. Adherence to established software engineering best practices, and a commitment to continuous learning about operating system internals and security principles are crucial for making sound professional judgments. Question 12. Quality control measures reveal that a development team is rapidly adopting serverless computing for a new application, citing significant cost reductions and faster time to market. However, initial reviews indicate a lack of detailed security configurations for the serverless functions, with a reliance on default provider settings and minimal attention to data encryption for sensitive user information processed by these functions. Which approach best upholds professional software development standards and regulatory expectations for a certified software development professional (CSDP). Option A. Immediately halt further serverless adoption until a comprehensive security architecture review is completed, focusing on granular access controls, data encryption strategies, and robust logging for all serverless functions. Option B. Proceed with the current serverless adoption strategy, assuming the cloud provider's built-in security measures are sufficient and will be enhanced in future development sprints. Option C. Implement basic security measures, such as enabling multi-factor authentication for developer access, and defer detailed security configuration for serverless functions to a later phase after initial deployment. Option D. Focus solely on optimizing the serverless functions for performance and cost, and address any security concerns that arise post-deployment through reactive patching. Correct answer is A. Immediately halt further serverless adoption until a comprehensive security architecture review is completed, focusing on granular access controls, data encryption strategies, and robust logging for all serverless functions. Explanation. This scenario presents a common challenge in cloud adoption, balancing the benefits of serverless computing with the need for robust security and compliance, particularly within the context of the Certified Software Development Professional (CSDP) certification's implied regulatory environment, which emphasizes adherence to established best practices and potential industry-specific regulations. Though no specific jurisdiction is provided, CSDP implies a professional standard akin to US or UK professional engineering/development ethics. The challenge lies in ensuring that the perceived simplicity and cost-effectiveness of serverless do not lead to overlooking critical security configurations and data governance, which are paramount for professional software development. The correct approach involves a comprehensive security assessment that integrates with the serverless architecture from the outset. This means understanding the shared responsibility model of cloud providers, implementing granular access controls, IAM policies, ensuring data encryption at rest and in transit, and establishing robust logging and monitoring mechanisms. This proactive, security by design methodology aligns with professional software development ethics that prioritize the integrity, confidentiality, and availability of systems and data. It also implicitly adheres to general principles of data protection and system security that are foundational to professional certifications like CSDP, ensuring that the developed software is not only functional, but also secure and compliant with potential future regulatory mandates. An incorrect approach would be to solely focus on the cost savings and rapid deployment capabilities of serverless functions without a commensurate investment in security. This might manifest as using default configurations, neglecting to implement least privilege principles for function execution roles, or failing to encrypt sensitive data processed by these functions. Such an approach would be professionally unacceptable because it directly contravenes the fundamental duty of a software professional to build secure and reliable systems. It exposes the organization to significant risks, including data breaches, unauthorized access, and noncompliance with potential data privacy regulations, which could lead to severe reputational damage and legal repercussions. Another incorrect approach would be to assume that the cloud provider's inherent security features are sufficient without performing independent validation and configuration. While providers offer robust security, misconfigurations by the user are a leading cause of cloud security incidents. Over-reliance on provider defaults without tailored security measures is a failure of due diligence. A professional decision-making process for such situations should involve a risk-based assessment. This begins with understanding the data sensitivity and compliance requirements associated with the application. Then, evaluate the chosen cloud service model, serverless in this case, and its specific security implications. Implement security controls that are commensurate with the identified risks, prioritizing a defense-in-depth strategy. Continuous monitoring and regular security audits are crucial to adapt to evolving threats and ensure ongoing compliance. Professionals must always err on the side of caution when security is concerned, prioritizing robust security measures over perceived convenience or cost savings. Question 13. Investigation of a critical production bug requires an immediate fix. The development team is under immense pressure to deploy the solution within the hour. The lead developer proposes to bypass the standard branching and merging procedures in Git, committing the fix directly to the main branch, and initiating a manual build and deployment process to expedite the release. What is the most professionally responsible course of action? Adhering to the principles of software configuration management and professional software development ethics. Option A. Commit the fix directly to the main branch and initiate a manual build and deployment to meet the 1-hour deadline. Option B. Implement the fix without using any version control or configuration management tools, focusing solely on getting the code into production as quickly as possible. Option C. Create a dedicated hotfix branch, implement the fix, thoroughly test it in an isolated environment, and then merge it back into the main branch through the established CI/CD pipeline, even if it slightly exceeds the 1-hour target. Option D. Develop the fix in a separate, unmanaged branch and deploy it directly from that branch without merging it back into the main development line. The correct answer is C. Create a dedicated hotfix branch, implement the fix, thoroughly test it in an isolated environment, and then merge it back into the main branch through the established CI/CD pipeline, even if it slightly exceeds the 1-hour target. Explanation. This scenario presents a professional challenge due to the inherent conflict between the immediate need to deploy a critical fix and the established processes designed to ensure software quality and security. The pressure to release quickly can tempt developers to bypass or shortcut established software configuration management (SCM) practices, particularly those related to version control, branching, and continuous integration. The CSDP certification implies a commitment to professional standards that prioritize integrity, competence, and the public interest, which in this context translates to delivering secure and reliable software. Careful judgment is required to balance the urgency of the situation with the long-term implications of compromised development and deployment practices. The correct approach involves adhering to established SCM processes, even under pressure. This means utilizing proper branching strategies to isolate the fix ensuring it undergoes thorough testing within an integrated environment, (SI), and then merging it back into the main development line only after validation. This approach upholds the principles of software engineering best practices, which are implicitly part of the professional standards expected of a certified software development professional. Specifically, it aligns with the need for traceability, auditability, and risk mitigation inherent in robust SCM, the regulatory framework for software development. While not explicitly detailed here as per the prompt's constraint to focus on the exam's implied jurisdiction, generally emphasizes due diligence, quality assurance, and the prevention of defects that could lead to system failures or security vulnerabilities. By following these established procedures, the developer ensures that the fix is not only functional but also integrated safely and predictably, minimizing the risk of introducing new issues. An incorrect approach of directly committing the fix to the main branch without proper branching or testing introduces significant risks. This bypasses the essential quality gates of the CI pipeline, meaning the fix is not automatically built, tested, or scanned for vulnerabilities in an integrated environment. This failure to integrate and test can lead to the introduction of regressions or new bugs that might not be immediately apparent, potentially causing more severe issues than the original problem. Ethically, this shortcuts due diligence and compromises the integrity of the software development process, potentially leading to the deployment of unstable or insecure code. Another incorrect approach of creating a separate, unmanaged branch for the fix and deploying it directly from there without a formal merge process into the main development line also presents serious problems. While it isolates the change, it creates a divergence that is difficult to track and integrate later. This lack of proper merging means the fix might not be incorporated into future development efforts, leading to its eventual loss or the need for re-implementation. Furthermore, deploying from an unmanaged branch bypasses the controlled release management procedures, making it difficult to audit the deployment history and ensure consistency across environments. This undermines the principles of configuration management and can lead to an unmanageable codebase. A third incorrect approach of deploying the fix without any version control or configuration management whatsoever is fundamentally flawed. This completely disregards the core tenets of SCM, leading to a loss of traceability, an inability to revert to previous stable states, and a high risk of introducing inconsistencies. It makes auditing impossible and significantly increases the likelihood of deployment errors and security vulnerabilities. This approach is a direct violation of professional responsibility to maintain a controlled and auditable software development lifecycle. The professional decision-making process in such situations should involve 1. Assessing the true urgency and impact of the issue. 2. Evaluating the risks associated with deviating from established SCM processes. 3. Communicating the situation and proposed solutions to stakeholders, including the potential risks of expedited processes. 4. Prioritizing adherence to core SCM principles, versioning, integration testing, even if it requires a slight delay, or if an expedited path is absolutely necessary, ensuring that critical quality and security checks are still performed, albeit perhaps in a more focused manner. The goal is always to deliver a reliable and secure product, and compromising fundamental processes for speed should be a last resort, undertaken with full awareness and mitigation of the associated risks. Question 14. Compliance review shows that the software development team for a critical financial system has been consistently missing documentation deadlines, leading to delays in user acceptance testing and audit readiness. The team has proposed several approaches to address this, which approach best balances the need for comprehensive documentation with efficient development practices, adhering to professional standards for software development. Option A. Implement a strategy that prioritizes automated generation of API documentation, uses inline code comments to explain complex logic, and maintains a concise, version-controlled requirements document that is updated iteratively. Design documentation will be generated as needed for major architectural changes and stored in a central repository. User manuals will be developed in parallel with feature development, with a focus on clear task-oriented instructions. Option B. Rely primarily on informal, ad hoc documentation such as meeting notes, email threads, and whiteboard sketches to capture design decisions and requirements, with the understanding that developers will verbally explain critical aspects to new team members. Option C. Mandate the creation of exhaustive, formal documentation for all aspects of the software, including detailed design specifications, comprehensive user guides for every possible scenario, and extensive inline code comments to be completed entirely before the commencement of user acceptance testing. Option D. Focus solely on generating detailed code comments that explain every line of code, assuming that developers can infer requirements and design from the code itself, and defer the creation of user manuals and API documentation until after the software has been deployed. The correct answer is A. Implement a strategy that prioritizes automated generation of API documentation, uses inline code comments to explain complex logic, and maintains a concise, version-controlled requirements document that is updated iteratively. Design documentation will be generated as needed for major architectural changes and stored in a central repository. User manuals will be developed in parallel with feature development, with a focus on clear, task-oriented instructions. Explanation. This scenario presents a common challenge in software development, balancing the need for comprehensive documentation with the practicalities of agile development cycles and resource constraints. The professional challenge lies in ensuring that documentation, a critical artifact for maintainability, compliance, and user understanding, is not sacrificed in the pursuit of rapid delivery. Careful judgment is required to identify documentation practices that are both effective and efficient, adhering to the principles of good software engineering and any applicable regulatory requirements for the Certified Software Development Professional (CSDP) certification. The correct approach involves a tiered strategy for documentation, prioritizing essential artifacts while leveraging modern tools and techniques for efficiency. This includes maintaining up-to-date requirements documentation that clearly defines scope and acceptance criteria, robust design documentation that outlines architectural decisions and key components, and user-friendly manuals tailored to different user roles. API documentation should be generated automatically where possible, and code comments should serve as a concise explanation of complex logic, rather than a substitute for design documentation. The use of integrated documentation tools that link directly to the codebase and facilitate collaborative updates is also crucial. This approach aligns with professional ethical obligations to produce high-quality, maintainable software, and to ensure that users and other developers can effectively understand and interact with the system. It also implicitly supports compliance with any regulatory frameworks that mandate clear traceability and understanding of software functionality, which are often implicit in professional certifications like CSDP. An incorrect approach that focuses solely on generating extensive, static documentation at the end of development phases would be inefficient and prone to becoming outdated quickly. This fails to provide timely information to development teams and stakeholders, increasing the risk of misunderstandings and rework. It also neglects the opportunity to leverage automated documentation generation, which is a recognized best practice for API and code-level documentation. Another incorrect approach that relies heavily on informal, ad hoc documentation, such as scattered notes or emails, would be professionally unacceptable. This lack of centralized, structured documentation makes it difficult to track changes, ensure consistency, and onboard new team members. It also poses significant risks for long-term maintainability and knowledge transfer, potentially violating implicit professional duties to ensure the longevity and understandability of the software. A third incorrect approach that prioritizes code comments as the primary form of technical documentation would be insufficient. While code comments are valuable for explaining specific implementation details, they cannot replace higher-level design documentation or requirement specifications. Over-reliance on comments can lead to redundant or conflicting information if not meticulously maintained alongside the code, and it fails to provide the necessary context for architectural decisions or user-facing functionality. The professional reasoning process for making these decisions should involve a risk-based assessment of documentation needs. This means identifying what documentation is critical for regulatory compliance, security, maintainability, and user adoption. It also involves evaluating the cost-benefit of different documentation strategies, leveraging available tools and automation, and fostering a culture where documentation is seen as an integral part of the development process, not an afterthought. Professionals should continuously evaluate and adapt their documentation practices to ensure they remain effective and efficient throughout the software lifecycle. Question 15. The evaluation methodology shows that a large financial institution aims to leverage big data technologies and AI to enhance its customer service and fraud detection capabilities. The proposed approach involves ingesting massive datasets from various sources, including transaction histories, customer interactions, and demographic information, into a Hadoop cluster. Subsequently, Spark will be used for real-time data processing and feature engineering. The institution then plans to deploy machine learning models, including deep learning, to predict customer churn and identify fraudulent activities. Which of the following approaches best aligns with responsible data development and regulatory compliance within the specified exam jurisdiction? Option A. Implement the AI models directly on raw, unprocessed data to minimize processing time and complexity, relying on the inherent capabilities of the AI algorithms to automatically handle data inconsistencies and biases. Option B. Prioritize the immediate deployment of advanced AI models on the processed data to achieve rapid insights and demonstrate technological prowess, with a plan to address potential data bias and privacy concerns retrospectively. Option C. Focus on maximizing data collection from all available sources to create the largest possible dataset, assuming that more data will inherently lead to better AI performance, and deferring detailed data quality and bias analysis until after the initial model development phase. Option D. Establish a comprehensive data governance framework, including data quality checks, lineage tracking, and access controls, before extensive data ingestion. Concurrently, conduct thorough bias assessments on the datasets and develop strategies for bias mitigation in the AI models, ensuring transparency in data usage and model decision-making. The correct answer is B. Prioritize the immediate deployment of advanced AI models on the processed data to achieve rapid insights and demonstrate technological prowess, with a plan to address potential data bias and privacy concerns retrospectively. Explanation. This scenario is professionally challenging because it requires balancing the technical capabilities of big data technologies with the ethical and regulatory obligations surrounding data privacy and responsible AI development. The CSDP professional must navigate the complexities of data governance, bias mitigation, and transparent data usage, all within the defined regulatory framework for the exam's jurisdiction. Careful judgment is required to ensure that the pursuit of advanced analytics and AI does not inadvertently lead to discriminatory outcomes or breaches of trust. The correct approach involves a phased implementation that prioritizes data governance and bias detection before deploying AI models. This means establishing clear data lineage, implementing robust data quality checks, and actively seeking and mitigating bias in datasets and algorithms. This aligns with regulatory principles that emphasize fairness, accountability, and transparency in automated decision-making systems. By proactively addressing these concerns, the professional upholds ethical standards and minimizes legal and reputational risks. An incorrect approach that immediately focuses on deploying advanced AI models without adequate data governance or bias assessment fails to meet regulatory expectations. Such an approach risks perpetuating or amplifying existing societal biases present in the data, leading to discriminatory outcomes. This is a direct violation of principles of fairness and non-discrimination, often enshrined in data protection and AI ethics guidelines. Furthermore, a lack of clear data lineage and quality control undermines accountability and makes it difficult to audit or explain the AI's decisions, which can be a regulatory failure. Another incorrect approach that prioritizes the collection of vast amounts of data for the sake of potential future analysis, without a clear purpose or consideration for privacy, is also problematic. This can lead to overcollection of sensitive information, increasing the risk of data breaches and violating data minimization principles. Regulations often mandate that data collected should be adequate, relevant, and limited to what is necessary for the specified purposes. The professional decision-making process for similar situations should involve a risk-based approach. First, understand the regulatory landscape and ethical considerations relevant to the data and the intended AI application. Second, establish a strong data governance framework, including data quality, lineage, and access controls. Third, conduct thorough bias assessments of both the data and the proposed AI models, and implement mitigation strategies. Fourth, develop a clear plan for model deployment, monitoring, and ongoing evaluation, ensuring transparency and explainability where possible. Finally, engage stakeholders to ensure alignment and address concerns throughout the development lifecycle. Question 16. When evaluating the integration of a new AI-powered predictive analytics module into a customer relationship management (CRM) system, which risk assessment approach best aligns with the principles of responsible software development and regulatory compliance? Option A. Prioritize the technical performance and accuracy metrics of the AI module, assuming regulatory compliance will be addressed post-deployment through general security audits. Option B. Focus primarily on the cost-effectiveness and speed of integrating the AI module, deferring detailed ethical and legal reviews until after the system is operational and user feedback is gathered. Option C. Conduct a thorough risk assessment that specifically examines potential biases in the AI model's training data, the transparency of its decision-making processes, and the security of data handled by the module, aligning with data protection and fairness principles. Option D. Assess the AI module's novelty and potential for market differentiation, with a secondary consideration for security, assuming that established CRM security protocols will inherently cover the AI components. The correct answer is A. Prioritize the technical performance and accuracy metrics of the AI module, assuming regulatory compliance will be addressed post-deployment through general security audits. Explanation. This scenario presents a professional challenge due to the inherent complexities and evolving nature of emerging technologies like AI and ML within a regulated software development environment. The core difficulty lies in balancing innovation and the adoption of powerful new tools with the stringent requirements for data privacy, security, and ethical considerations mandated by regulatory frameworks. Professionals must exercise careful judgment to ensure that the implementation of these technologies does not inadvertently lead to noncompliance, data breaches, or biased outcomes, all of which carry significant legal and reputational risks. The correct approach involves a comprehensive risk assessment that specifically identifies and evaluates potential vulnerabilities and impacts associated with AI/ML integration. This includes scrutinizing data sources for bias, assessing the explainability and transparency of ML models, and ensuring robust security measures are in place to protect sensitive information processed by these systems. This approach is correct because it directly addresses the regulatory obligations to protect user data, prevent discrimination, and maintain system integrity. For instance, regulations like GDPR, if applicable to the exam jurisdiction, mandate data minimization, purpose limitation, and the right to explanation, all of which are directly impacted by AI/ML deployments. A proactive risk assessment ensures that these principles are embedded from the design phase, aligning with the privacy by design and security by design principles often enshrined in software development standards and regulations. An incorrect approach that focuses solely on the technical capabilities of AI/ML without considering regulatory implications fails to meet professional standards. This oversight can lead to the deployment of systems that, while technically advanced, violate data protection laws by collecting excessive personal data or using it for unauthorized purposes. Another incorrect approach that prioritizes rapid deployment over thorough validation of AI/ML model fairness and accuracy is ethically and legally unsound. Such an approach risks perpetuating or amplifying societal biases present in training data, leading to discriminatory outcomes and potential legal challenges. Furthermore, neglecting to assess the security implications of integrating AI/ML components could expose the system to new attack vectors, jeopardizing data confidentiality and integrity, which are fundamental regulatory requirements. Professionals should employ a structured decision-making process that begins with understanding the specific regulatory landscape applicable to their development context. This involves identifying all relevant laws, standards, and ethical guidelines. Subsequently, a thorough risk assessment framework should be applied to the proposed use of emerging technologies, considering technical, ethical, and legal dimensions. This assessment should inform design choices, development practices, and deployment strategies, ensuring that compliance and ethical considerations are integrated throughout the software development lifecycle, rather than being an afterthought. Question 17. Strategic planning requires a software development team to integrate several third-party libraries into a new product, The project deadline is aggressive, and the team lead is aware that some of these libraries are open source, while others have been provided by a partner without explicit licensing documentation. The team lead is considering proceeding with integration to meet the deadline, assuming the open source licenses are permissive and that the partner's code is implicitly licensed for use, which approach best upholds legal and ethical considerations for software development. Option A. Integrate the libraries and address licensing concerns post-launch, prioritizing product delivery. Option B. Proceed with integration, assuming open source licenses are permissive and the partner's code is implicitly licensed to meet the aggressive deadline. Option C. Use only the open source libraries, assuming their licenses are fully permissive, and avoid the partner's code due to the lack of documentation. Option D. Conduct a thorough review of all third-party library licenses, including requesting explicit documentation from the partner, and ensure compliance with all terms before integration. The correct answer is D. Conduct a thorough review of all third-party library licenses, including requesting explicit documentation from the partner, and ensure compliance with all terms before integration. Explanation: this scenario is professionally challenging because it requires balancing business objectives with strict adherence to intellectual property laws and ethical development practices. The pressure to deliver a product quickly can lead to shortcuts that violate copyright or patent rights, exposing the company to significant legal and financial repercussions. Furthermore, the use of third-party code without proper licensing can undermine the integrity of the software and the company's reputation. Careful judgment is required to ensure that all software components are legally sourced and that the development process respects intellectual property rights. The correct approach involves a thorough due diligence process to identify and verify the licensing of all third-party components. This includes understanding the terms and conditions of each license, ensuring compliance, and documenting this compliance. This approach is right because it directly addresses the legal and ethical obligations surrounding software licensing and intellectual property. Specifically, it aligns with the principles of copyright law, which grants exclusive rights to creators, and patent law, which protects inventions. By verifying licenses, developers ensure they are not infringing on these rights, thereby avoiding legal disputes and penalties. This also upholds professional conduct by demonstrating respect for intellectual property and responsible software development. An incorrect approach of proceeding with development without verifying licenses is professionally unacceptable because it constitutes a direct violation of copyright and potentially patent law. This failure to conduct due diligence creates a high risk of infringement, leading to potential lawsuits, injunctions, and significant financial damages. It also breaches ethical considerations by disregarding the rights of intellectual property owners. Another incorrect approach of assuming open-source licenses are permissive without understanding their specific terms is also professionally unacceptable. Many open-source licenses have specific obligations, such as requiring attribution or the disclosure of derivative works. Failing to adhere to these terms, even with seemingly free software, can lead to license violations and legal challenges. This demonstrates a lack of professional diligence and an ethical lapse in respecting the conditions under which software is made available. A third incorrect approach of attempting to obscure the use of unlicensed or improperly licensed third-party code is ethically reprehensible and legally perilous. This constitutes a deliberate attempt to circumvent intellectual property laws and can be viewed as fraudulent. It severely damages professional integrity and exposes the company to severe penalties, including criminal charges in some jurisdictions. The professional decision-making process for similar situations should involve a proactive approach to legal and ethical considerations. This includes 1. Establishing clear policies and procedures for software acquisition and development that explicitly address licensing and intellectual property. 2. Educating development teams on relevant laws and ethical best practices. 3. Implementing a robust process for vetting all third-party components, including thorough license review and legal consultation when necessary. 4. Maintaining comprehensive documentation of all licensing agreements and compliance efforts. 5. Prioritizing legal and ethical compliance over short-term business expediency. Question 18. Analysis of a scenario where a front-end development team is tasked with rapidly integrating a new, feature-rich third-party JavaScript library into a customer-facing web application to meet an aggressive product launch deadline. The library promises significant improvements in user interface responsiveness and interactivity. However, the library's source code has not been independently audited for security vulnerabilities, and its data handling practices are not fully documented. What is the most professionally responsible approach to mitigate potential risks associated with this integration? Option A. Immediately integrate the JavaScript library to meet the product launch deadline, assuming the vendor's reputation implies a secure product. Option B. Perform a basic malware scan on the JavaScript library's files and proceed with integration if no immediate threats are detected. Option C. Conduct a thorough security review of the third-party JavaScript library, including code analysis, vulnerability scanning, and assessment of its data handling mechanisms, before proceeding with integration. Option D. Integrate the JavaScript library and rely solely on the vendor's assurances regarding its security and data privacy compliance. Correct answer is C. Conduct a thorough security review of the third-party JavaScript library, including code analysis, vulnerability scanning, and assessment of its data handling mechanisms, before proceeding with integration. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid feature deployment and the imperative to maintain robust web security, particularly within the context of the Certified Software Development Professional (CSDP) certification's emphasis on professional responsibility and adherence to established best practices. The need to integrate a new third-party JavaScript library without thorough vetting introduces significant risks that could compromise user data and application integrity, directly impacting the trust and reliability expected of a CSDP. Careful judgment is required to balance business demands with the ethical and professional obligations to protect users and the system. The correct approach involves a comprehensive risk assessment and security review of the third-party JavaScript library before integration. This process should include analyzing the library's source code for vulnerabilities, understanding its data handling practices, checking its reputation and update history, and considering its potential impact on the application's overall security posture. This aligns with the CSDP commitment to developing software that is not only functional but also secure and reliable. Ethically, this approach prioritizes user safety and data privacy, fulfilling the professional duty of care. Regulatory frameworks, while not explicitly detailed for this exam's jurisdiction, generally mandate that software professionals take reasonable steps to prevent harm and protect sensitive information, which this approach directly addresses. An incorrect approach of immediately integrating the library to meet a tight deadline without any security review is professionally unacceptable. This failure constitutes a breach of the duty of care, as it knowingly exposes the application and its users to potential security threats, such as cross-site scripting, XSS, attacks, data exfiltration, or the introduction of malware. Such an oversight could lead to significant reputational damage, legal liabilities, and a violation of implicit or explicit user trust. Another incorrect approach of relying solely on the third-party vendor's claims of security without independent verification is also professionally unsound. While vendor assurances are a starting point, they do not absolve the software professional of their responsibility to conduct due diligence. This approach neglects the principle of independent verification, a cornerstone of robust security practices, and could lead to the adoption of a compromised library. A third incorrect approach of only performing a superficial scan for known malware signatures without a deeper code review or analysis of the library's behavior is insufficient. While malware scanning is a necessary step, it is not exhaustive. Vulnerabilities can exist that are not detected by signature-based scans, and the library's intended functionality might still pose security risks if not properly understood and mitigated. The professional decision-making process for similar situations should involve a structured risk management framework. This includes identifying potential threats and vulnerabilities associated with new components, assessing the likelihood and impact of these risks, and implementing appropriate mitigation strategies. For third-party code, this means prioritizing security reviews, understanding data flows, and ensuring compliance with relevant security standards and best practices before integration. When faced with conflicting pressures, such as tight deadlines, professionals must advocate for the necessary time and resources to perform these critical security evaluations, escalating concerns, if necessary, to ensure the integrity and security of the developed software. Question 19. Benchmark analysis indicates that a critical feature in a new financial reporting application involves parsing user-uploaded CSV files and storing the data in a persistent database. The development team is under pressure to meet a tight deadline. The lead developer proposes to implement the parsing logic without explicit exception handling for potential file I/O errors, e.g., file not found, insufficient permissions, or data format inconsistencies within the CSV, assuming these scenarios are rare and will be handled by the operating system, which approach best aligns with the professional responsibilities of a certified software development professional, CSDP, in managing the risks associated with this development task. Option A. Delegate all error handling responsibilities to the underlying database system, assuming it will manage any data integrity issues arising from the parsed CSV content. Option B. Implement basic error logging for file operations and data parsing, but do not include specific recovery mechanisms or user feedback, as the primary focus is on feature delivery. Option C. Proceed with the proposed implementation, relying on the operating system to manage any file I/O errors and assuming data integrity based on the assumption of rare inconsistencies. Option D. Implement comprehensive exception handling for all file operations and data parsing steps, including validation of CSV structure and data types, with defined strategies for user notification and data recovery or graceful degradation. The correct answer is D. Implement comprehensive exception handling for all file operations and data parsing steps, including validation of CSV structure and data types, with defined strategies for user notification and data recovery or graceful degradation. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between rapid feature development and the critical need for robust error handling and data integrity, especially within a regulated software development environment. The pressure to deliver new functionality can lead to shortcuts that compromise the reliability and security of the software, potentially exposing users to data loss or corruption. A CSDP professional must balance business demands with their ethical and professional responsibility to produce high-quality, secure, and reliable software. The challenge lies in identifying and mitigating risks associated with incomplete error handling before deployment, which could have significant consequences. Correct approach analysis. The correct approach involves implementing comprehensive exception handling mechanisms that capture and gracefully manage potential errors during data processing and file operations. This includes validating input data, anticipating potential file access issues, e.g., permission, non-existent files, disk full, and defining clear strategies for recovery or graceful degradation when errors occur. This aligns with professional software engineering best practices and the implicit ethical obligation to deliver software that is reliable and protects user data. While specific regulations for CSDP might not explicitly dictate every exception handling pattern, the underlying principles of due diligence, risk management, and producing fit-for-purpose software are universally expected. This approach ensures that the software behaves predictably even in adverse conditions, minimizing the risk of data loss or corruption. Incorrect approaches analysis. Ignoring potential exceptions during file operations and data parsing is a significant ethical and professional failure. This approach, which assumes all operations will succeed, directly leads to unpredictable software behavior and potential data corruption or loss. It violates the principle of producing reliable software and demonstrates a lack of due diligence in risk assessment. Implementing only basic error logging without a defined recovery or user notification strategy is also professionally inadequate. While logging is a component of error handling, it does not address the immediate impact of an error on the user or the system state. This approach fails to mitigate the actual risk of data loss or corruption, leaving the system vulnerable to cascading failures. Relying solely on the operating system's default error handling for file operations and data parsing is insufficient. Operating system errors are often low-level and may not provide the necessary context or control for application-level recovery. A professional software developer must anticipate and handle errors at the application level to ensure graceful degradation and data integrity, rather than deferring responsibility to a system that may not offer the required robustness. Professional reasoning. Professionals should adopt a risk-based approach to software development. This involves proactively identifying potential failure points, especially in areas involving external interactions like file I/O and data parsing. A structured decision-making process would include 1. Threat modeling. Identify potential threats and vulnerabilities related to data handling and file operations. 2. Impact assessment. Determine the potential consequences of these threats, e.g., data loss, corruption, security breaches. 3. Mitigation strategy. Design and implement robust error handling, input validation, and recovery mechanisms. 4. Testing. Rigorously test error handling scenarios to ensure they function as expected. 5. Continuous improvement. Regularly review and update error handling strategies based on operational feedback and evolving threats. Question 20. Process analysis reveals that a mobile application development team is under pressure to release a new version with several user-requested features by a tight deadline. The team has identified potential security vulnerabilities during internal testing, but addressing them thoroughly would significantly delay the release. What is the most professionally responsible approach to manage this situation? Option A. Implement the new features with minimal security checks and rely on user feedback and post-deployment security patches to address any discovered vulnerabilities. Option B. Conduct a rapid security assessment to identify critical vulnerabilities that pose an immediate threat and address only those before release, deferring less critical issues to a subsequent update. Option C. Delay the release of the new version until all identified security vulnerabilities are thoroughly addressed and validated. Option D. Prioritize the release of new features and schedule a comprehensive security review and remediation after the initial deployment. Correct answer is D. Prioritize the release of new features and schedule a comprehensive security review and remediation after the initial deployment. Explanation. Scenario analysis. This scenario presents a common challenge in mobile application development where a team must balance the desire for rapid feature delivery with the imperative of maintaining robust security and compliance. The professional challenge lies in navigating the trade-offs between speed, cost, and adherence to established security protocols and potential regulatory requirements relevant to software development, particularly concerning data privacy and integrity. The need for careful judgment stems from the potential for security vulnerabilities to lead to data breaches, reputational damage, and legal repercussions, all of which can significantly impact the success and sustainability of the application and the organization. Correct approach analysis. The correct approach involves a comprehensive security review integrated into the development lifecycle, prioritizing the identification and remediation of vulnerabilities before deployment. This aligns with best practices in secure software development, emphasizing a shift-left security strategy. By incorporating security testing, code reviews, and threat modeling early and continuously, developers can proactively address potential weaknesses. This methodology is ethically sound as it demonstrates a commitment to protecting user data and maintaining the integrity of the application. From a regulatory perspective, while specific CSDP exam regulations are not provided, general principles of due diligence in software development mandate that reasonable steps be taken to ensure the security of applications, especially those handling sensitive information. This proactive stance minimizes the risk of non-compliance with data protection laws and industry standards. Incorrect approaches analysis. Prioritizing feature deployment over security testing introduces significant risks. This approach is ethically questionable as it potentially exposes users to harm through vulnerabilities. It also fails to uphold the professional responsibility of a software developer to deliver secure and reliable products. Regulatory failure would occur if such vulnerabilities led to a data breach, potentially violating data protection regulations that require reasonable security measures. Relying solely on post-deployment security audits, while better than no testing, is a reactive rather than proactive measure. This approach is less effective because vulnerabilities discovered after deployment have already had the potential to be exploited. It represents a missed opportunity to prevent issues and can be more costly and time-consuming to fix. Ethically, it suggests a lower standard of care than a proactive security posture. Implementing security measures only when specific vulnerabilities are reported by users or external parties is a highly reactive and insufficient strategy. This approach demonstrates a lack of foresight and a failure to meet professional obligations to anticipate and mitigate risks. It is ethically indefensible as it places the burden of security discovery on end users and is likely to result in significant security incidents and regulatory noncompliance. Professional reasoning. Professionals should adopt a risk-based approach to security, integrating it throughout the software development lifecycle. This involves continuous assessment, testing, and remediation. Decision-making should be guided by a commitment to user safety, data integrity, and adherence to professional standards and any applicable regulatory frameworks. When faced with competing priorities, security should not be treated as an optional add-on, but as an intrinsic component of quality software development.